Hello, there is a problem number 3, and we are given two trees, and we have to check if one tree is a subtree of another. So in this problem, for example, we have one tree and we have another tree, and according to assignment, we have to check if this second tree is a subtree of the first one. So how are we gonna do this? In order to solve this problem, actually, I'm gonna use two functions instead of one. First function method I will use just to check nodes of each tree. I mean, not tree, but actually part of the tree. So for example, I will check just if nodes of a tree are equal to each other or not, and if the children's of the node also are equal to each other. For example, we will start from checking from this point of root of two trees, and I will just check if data in the nodes are equal to each other or not. If they're not, I will just return false. Or instead of that, I will just move to another node to its children, and from that I will just starting checking if it's equal to each other or not. So at this point I will see that the data in those nodes are equal to each other. After that I will check the children of that nodes and check if it is equal to each other or not. After checking it, I will just use another function where I will try recursively go through each node. For example, one function will just check given nodes of a subtree if they are equal to each other or not, and another function will be will allow us to move through all nodes of the tree until it will reach the bottom of the tree, and after that, if we will not find any equations, we will just return false. But if at some point we'll find some equations between nodes, we'll just keep checking other children of that node if they're equal or not. So how it's gonna look like in the function hour. So first function will look like as follow. It will return a boolean, and I called it r equal function, and first node will be like t1 and the second node will be t2, and here I will check if those nodes are equal or not. So if they're null, if they're null in the sentence, so instead of or I will use and. So I will return true, but if just one of the nodes will be or will be equal to null, I will return false, meaning that those nodes are not equal to each other. And at the end I will also return if t1 data equal to t2 data, and I will go deep down recursively and will check if the children of that node are also equal to each other or not, like t1 left and t2 left using this r== function, and at the same time, and again recursively go down to the right child. So t1 right and t2 right. So just in case all children will return true, I will return true for this function. And second function will be just go through all, just to move between nodes of our original tree. So the return will be also Boolean, and I call it is sub3. So here we are given node T, the original one, and node S, which will be actually the smaller tree, which we will be checking if it's a subtree of given main tree, which is T. So here I will check just if at some point our S value will be null. I will just return true, meaning that if it's null, so it's definitely the subtree. But for T, if it's null, I will return false. So if at some point we'll go down to the bottom of the tree with the null value, it will mean that we were not able to find any equations, and we failed to return true. And after that, I will call for r== function, where I will pass just this T and S trees, and if they will be equal, so like if at some point the node that we will be passing here will return equal from this function, so it will mean that actually our S3, which is smaller, is a subtree of our main tree. So at this point I will just return true. But if we will not be able to find an equation, we'll just move to another node of our main tree. So I will call this sub3 function again recursively, and will pass instead of T the children's of the tree, but S will be passed as it is, because we're actually checking if there is such a tree inside of our main tree. So, or here we're going down to the left child. Also, we will make the same check for the right child. So if at some point going down, it will find an equation of this row, it will return true. Otherwise, when it will reach the down of the tree, it will return false. So time complexity for this particular function will be, in the worst case, it will go through each node of a tree of 2 trees. So it will be m multiplied by n, where m and n are the number of nodes of these 2 trees, and the space complexity will be O of 1, because we are not declaring any additional data structure.